Hey, POE students, I'm going to take you through the couple of simple machines, couple more here. We're halfway done. We've got 3 left, and we're going to cover 2 in this video presentation / ed puzzle. We'll do inclined plane and wedge today, and we'll go to the screw later on. So here we go. Inclined plane, wedge, and screw are the last 3 simple machines we're going to talk about. All the mechanical advantage information from before, it's just redone in this presentation. It's exactly the same. Okay, so we've been through this a whole bunch of times, so we should not have that much of an issue with this. If you're still having problems understanding what mechanical advantage is, please let me know. IMA formula, exactly the same as it was for the wheel and axle, the lever, and the pulley, not the pulley, but the wheel and axle and the lever. AMA is the exact same formula as well. So let's talk about what an inclined plane is. It's a flat surface set in an angle or an incline. There's no moving parts. Okay, so basically what you're going to do is lift up something heavy by pushing or pulling it kind of up the ramp. Inclined plane IMA. This is where it gets us a little bit tricky because inclined plane and wedge are slightly different. The distance the effort moves here is, in the example that's here, is the 15 feet. Okay, the slope or the L on this ramp. If we do not know that, we can, if we only know the distance across the bottom of this ramp and the height of the ramp, we could use Pythagorean theorem to calculate this this distance here, this L. So you may have to do that, hint, hint, wink, wink. So that would be our IMA would be our slope, length divided by our height length, which gives us a mechanical advantage of 3.8 to 1. Okay, 15 divided by 4, 3.821. The AMA, same thing, resistance and effort forces. We need to know the forces for this. We've got a 50 pounds resistance force in this wagon here, looks like, and you only need to apply 20 pounds of effort force to push it up the ramp. So same formula, 50 divided by 20, 2.5 to 1. Okay, that is our actual mechanical advantage once we figure out the forces that we have here. Hey, the efficiency. AMA over IMA, out over in. 2.5 divided by 3.75 times 100 gives us only a 67% efficiency for the inclined plane. They're good, but they're not terribly efficient. And I'll pause here and let you do an ed puzzle question real quick as to why you think this is not terribly efficient. The wedge. A wedge is essentially a moving inclined plane. There's actually 2 inclined planes back to back here. It tapers. There's a thin edge used for splitting things, raising heavy bodies, or tightening or being driven into something. So we have a wedge here going into looks like a piece of wood. Here on the other picture, we have a wedge going down and our work piece, whatever it is, splitting apart. So wedge IMA, you're going to take the overall length of the wedge. Forget about this angle here, the length on this. Okay, we just want overall perpendicular to the height length and our height. So DE over DR, it's L over H. And the IMA of the wedge to the right is going to be, looks like we got 10 divided by 3. So 3.33 to 1. AMA, same thing. As every other AMA, we're doing forces. It's a little confusing because you have 700 to the left and 700 to the right. However, we're only going to count that one time, okay? Because they're only figuring what goes in one direction, and it's just the same go in the other direction. So don't add these together and come up with 1,400 pounds. 700 divided by my 250-pound smash with a hammer, and I come up with a mechanical advantage of 2.8 to 1. So the efficiency, again, AMA over IMA, 2.8 divided by 3.33, and I get an 84% efficient wedge. That's it. That's it for wedge and inclined plane. Good luck on this ed puzzle. And we're going to do some investigation in class with the inclined plane. The wedge is really, really hard to measure because if I smash something with a hammer, and it's really, really hard to get 700 pounds or 600 pounds or however much force I'm applying. We really don't have the testing equipment to measure that here at the high school. So we're going to just do some theory-based calculations with the wedge and move on from there. Thank you.